Hello and welcome to GLISA's video tutorial introducing the Great Lakes Water Level Dashboard tool. The Great Lakes Water Level Dashboard provides historical and current Great Lakes water level data via interactive graphs as well as short-term water level forecasts. This tool was developed by NOAA's Great Lakes Environmental Research Laboratory and helps users visualize and understand water level fluctuations through time. This video is meant to provide additional guidance for potential end users in the Great Lakes region and to help them navigate and better understand the tool and its applications. In this tutorial, I'll first walk through the tool and highlight key data features and outputs that will be helpful for users to assess historical water level changes and long-term trends. Then I'll provide an example demonstration of how this tool can be applied. Now, I'm going to transition to opening the tool. I'll do this by typing Great Lakes Water Level Dashboard into my browser. This will populate the NOAA Office for Coastal Management.gov site, which I'll select. I'll first be brought to a landing page where I have the option to read an overview of the tool, learn about its key features, and access additional information and resources. I'll open the tool by selecting Launch. This is the tool. Let me introduce the main features on this page. Starting with these two tabs, Long-Term Record and Master Gauge. Each lake has one master gauge, which this tab is referring to. The default upon opening this tool is for the Long-Term Record tab to be displayed, so I'm going to go over this tab first. You can select which lakes you want to see graphs for. We can see that Superior, Michigan-Huron, Erie, and Ontario have a blue check mark by default, signifying the associated graph is visible on the page. We see that St. Clair is also available but not selected. Scrolling down lets me see the graphs for the active lakes, corresponding with the blue check marks. There is an option to view the specific timescale you're interested in via the start year and end year. Also, you can switch between units by clicking this button to view graphs in metric units or meters, or imperial units or feet. Metric is the default selection when opening the tool. If at any time you have questions about the data or this tool, you can use this information button. Let's review the graph components. First, by observation, I see water level measurements on the y-axis and timescale on the x-axis. Below the chart, I see the legend or symbology for the active data on the graph. These data are long-term average, symbolized by an orange solid line, lake-wide average, symbolized with a blue solid line, lake-wide monthly, symbolized by a blue dot, and the upper and lower 6-month forecast, symbolized by dashed red lines and shaded area. These data will be applied to each active graph. You can view detailed water level measurements for each of these data by hovering over a date on the graph. A pop-up appears and you can read the measurements for a given data option. There is also a visual timeline in our graph area, an alternative to typing the start and end year into the boxes at the top of the page. I can use this scale bar below the graph to view the historical trends for different periods of time. As you move the slider, you can see the years in the current graph view change. You can also zoom to a specific time frame within the graph by clicking and dragging the graph over the period you want to zoom to. To return to the default extent, I'll click Update. Each graph will show a set of icons in the upper right corner which have various functions. These buttons will only adjust the graph you are currently reviewing. Starting with Zoom, select this to activate zoom functionality on the graph. Pan. Use this to navigate throughout the graph. Zoom in and out. These buttons add or retract roughly 6 months of the timeline on the graph. Autoscale. This displays the entire historical dataset on the graph. Home. This will display the default extent of the start year 2019 and the end year 2024 for the individual graph. Download a graph image for the given lake to a PNG file. I'll note here that the slider timeline does not display in the PNG file. Lastly, show or hide the time scale slider. On this tab, you have access to additional data options to add to your graphs. Selecting additional data options, I see the pre-selected data active on the graph that we just discussed, symbolized by a blue check mark. I can add and remove data here as needed. Let me go over each of these, first by deselecting these default data and reviewing each data option's symbology. The first group is monthly mean data, which has two options. Lake-wide. This is monthly lake-wide data from 1918 through present day, viewed as blue dots. Master gauge. This data is from 1850 through present day and available for each lake which has one master gauge and is viewed as a black diamond shape. Next is the annual data, which is derived from monthly data and includes four options. Lake-wide range. This includes data from 1918 through last year and is the difference between the highest and lowest monthly lake-wide average for each year. This is symbolized as a shaded blue area. Master gauge range. This includes data from 1860 through last year and is the difference between the highest and lowest monthly mean water level for each year at the master gauge. This is viewed as a pink shaded area. Master gauge average. This is the annual mean water level at the master gauges from 1860 through last year and is viewed as a blue line. Lake-wide average. This includes data from 1918 through last year and is viewed as a dark blue line. Moving on to the lake-wide records and statistics group, which has five options. Long-term average. This includes data from 1918 through last year and is viewed as an orange line. Low water datum. This chart datum is the threshold below which water levels should seldom fall, symbolized as a black line. Monthly average. This is mean lake-wide average water level for each month of the year from 1918 through last year and is symbolized by a blue dashed line. Monthly record. This shows the lowest and highest recorded monthly mean lake-wide average water level for each month of the year from 1918 through last year and is viewed as a yellow shaded area with dashed lines. Monthly record range. This is the lowest and highest recorded monthly mean lake-wide average across all months of the year from 1918 through last year. This is symbolized as a gray shaded area with dashed lines. Lastly is the current coordinated forecasts, which shows forecast of monthly mean lake-wide average water levels 6 months out and is viewed as a red shaded area with dashed lines. Now quickly I'll review the Master Gauge tab. Similarly, you can activate the lakes you want to learn about and select metric units or meters or imperial units or feet. The graph function is the same with hover pop-ups and upper right functions. What's different is you don't have any additional data options available on this tab. There are no timescales because this graph only shows a set group of data. Let's review them. Record levels for month. These are monthly averages across all years of data available in this tool. You can view the maximum and minimum, symbolized with a gray dashed line and shaded area, and the mean, which is a bold gray line. There's current year data, which tells you that this is 2024 data, daily average water level, symbolized as a thin blue line, and monthly average water level for month to date, viewed as a bold black line. Prior year, for 2023. This is daily average water level viewed as an orange line, and monthly average water level viewed as a bold red line. You can also view these data separate or combined using this button. So this tab is great if you want to look at current conditions or previous year's data and compare the trends. Now, I want to demonstrate how to use this tool's features and interpret the results with an example. I'm clicking back to the Long-Term tab. I want to look at Lake Michigan-Huron water level data between 2019 and 2022, a known high water level period. And I'll also set my units to imperial. First, I want to review the water level measurements at this lake. then compare to long-term trends. Let's check out our data options. I'm going to select lake-wide monthly average mean, lake-wide average annual, and long-term average lake-wide records data. The first thing I notice are high lake-wide and lake-wide average peaks in 2019 that begin to decrease in 2021. Compared to the orange long-term average line, I can tell water levels are above average at this time. I want to view the accurate measurements, so I'm going to hover over the graph briefly to jot these down. Next, I'm going to select the auto-scale icon on the graph, which will show me the long-term trends for the entire period of record, back to 1918. What's interesting is that Lake Michigan-Huron has exaggerated-looking peaks and valleys. What's clear is that continuous low water levels are present in the 2000s and 2010s for Lake Michigan-Huron. This is something I'd be interested in learning more about. I can zoom in here to explore more closely by clicking and dragging my mouse over the period on the graph. This was followed by an increase in water levels that began in 2015 and peaked around 2019, well above the long-term trend. This makes me wonder when the last time we saw a peak similar to 2019 levels. Using the sliding scale, I can observe that the recent peak is similar to 1985 levels, but still one of the highest water levels the lake has seen. So I've learned about long-term fluctuations and near-term water levels in Lake Michigan-Huron. I can easily save this graph for sharing with my team or my community. I'm also going to update again back to 2019 to 2022 with a push of a button and save these for comparison and sharing as well. And this concludes our demonstration for how to use the Great Lakes Water Level Dashboard. This is a useful tool to visualize water level data and trends over time and is easy to navigate. I hope that this video was helpful. This video was created by GLISA, a climate adaptation partnership team funded by the National Oceanic and Atmospheric Administration, dedicated to helping the Great Lakes region build lasting and equitable climate resilience. This is one of several tutorial videos intended to help make climate, weather, and coastal resilience tools more accessible to end users in the Great Lakes region, under a project funded by Michigan Sea Grant. There are also accompanying guidance documents available for each of the tools covered in these tutorial videos, available at the link in this video description. The guidance document contains contact information if you have any questions about the tool. This video and accompanying guidance document were created for educational purposes only and are in no way affiliated with the Great Lakes Water Level Dashboard or its developers.